function f(x), which is 2x cubed plus ax squared minus bxn minus 3. Is that a minus or plus? A plus 3. Okay, we have two missing values, a and b. And it says that we have a factor x minus 3. And when we divide by x minus 2, I have remainder 15. So when it is a factor, what that tells us is f is divisible by x minus 3. I should have 0 remainder here. So by the factor theorem, which I will write is f3 equals to 0. And also I will have f2 equals to 15 by the remainder theorem. So that are the two things we will have. So f3 equals to 0. f3 equals to 0. Let's put 3 into the function. So 2 times 27 plus a times 9 minus b times 3 plus 3 equals to 0. f2 equals to 15. So 2 times 2 cubed, which is 8, plus a times 2 squared, which is 4, minus b times 2 plus 3, that equals to 15, by expanding the equation. So what I will have here is 9a minus 3b equals to, okay, what's that? That's a 54. So it's a minus 57. We minus the 54 to the other side and minus the 3. And we can further divide by 3 on both sides. So it's 3a minus b equals to minus 19, I think. And we have to look at the other side. That's a 16 plus 4a minus 2b plus 3 equals to 15. So that's plus a 19. So 16 plus 3 is a 19. So 4a, and that's a minus 4. If I can move that to the other side, minus 19, that gives me minus 4. So divide by 2, 2a minus b equals to minus 2. So we can subtract between the equation. Let's say we subtract 1 and 2. Okay, subtract 1 and 2. What I get is a equals to 19 minus negative 2 is plus 2, which is minus 17. A will be minus 17. And b equals to, if you use number 2, b equals to 2a plus 2. b equals to negative 17 times 2 plus 2. That's minus 32. So f(x) equals to 2x cubed minus 17x squared plus 32x, and then plus a 3. Okay, that's what the equation should look like. But all of this is calculation. That's why I ask you to do this question by yourself at home. What you all need to do is the beginning to, well, if you can write out those two. That's the new thing we learn. So the factor theorem and the remainder theorem. If it's divisible by x minus 3, then f3 must be 0. If it's divisible by x minus 2, not divisible, so remainder is 15. So f2 must be 15. After you have that, you should be able to find the equation and then do all of the solving here. Okay, we already know that's the equation. Okay, that's the equation. it's given that x minus 3 is a factor. Right? X minus 3 is a factor. So my thinking about like, okay, fx is x minus 3 times what? Right? Times what? What equation should we have in this bracket? Is that a quadratic, a linear, or cubic? What kind of equation is that? Quadratic, because we have a linear and then we need a quadratic. What we can do to find this quadratic? You can use the table. Yeah, you can use the table method. So we put the coefficient of the f in the table. The coefficient of f is 2, negative 17, 32, and 3. And what value we should put here? 3. Okay, we should put a 3 here. Okay, we fill in this table. The first one is must be like the one directly above it, so we have 2 there. 2 times 3 give you 6. 6 minus 7 plus negative 17, which is minus 11. Minus 11 times 3 is minus 33, plus 32 is a minus 1. Minus 1 times 3 is a minus 3, minus 3 plus the 3 is a 0. So we must have a 0. We know that should be a 0. If it's not 0, which means I solved something wrong before. So it's a factor, then this box must be 0. And now what we can have inside is, this is 2x squared minus 11x minus 1. We don't really need to do long division. You can do long division, use the fx divided by x minus 3, but it's pretty slow to use long division. So now we have 2x squared minus 11x and minus 1. Can I factorize this quadratic further? Is it possible to factorize it first? What do you need to do to test it? Not complete. Before you complete the square, what is find discriminant to see whether it's possible to factorize or not. So discriminant is minus 11 squared minus 2 times a times c. That's definitely greater than 0 because it's all positive here. Uh, 4ac, sorry. b squared minus 4ac. Yeah. 4 times 2 times minus 1. But it's still definitely greater than 0 because the minus 1 will become a plus. So I can factorize that. So obviously a 2 and a 1 can't make an 11 for you. Okay, a 2 and a 1 can't give you an 11 by using the cross multiplication. So what's the last way we can use to factorize quadratic? Complete square. So complete square. No space here. Okay, let's complete square. I'll just keep writing here. So what we have is 2x squared minus 11x and minus 1. Okay, to complete square, what we need to do first? Take out the 2, so that's 2 bracket x squared minus 11 over 2x minus 11 over 2. Is that 1? Yeah, 1. That's 1. Yeah, 1 over 2. And inside we have 2x squared minus 11 over 2x. Okay, plus half of the b value squared and subtract half of the b value squared. And then minus a half. And now we have 2. Okay, the bracket is still here. Okay, don't forget the bracket. We still have a bracket outside of that. And then the inside we have x minus 11 over 4 squared for those 3 terms. And then we have minus 1 to 1 over 16 minus 16 over 8. That is 2 bracket. Still have this bracket, x minus 11 over 4 squared minus 1 to 9 over 16. Okay, so what's 1 to 9? Let's see, 1 to 9 divided by 3 is 43. It's not really some good number. It's not a square number. So I can put that into square root 1 to 9 over 4 and then squared. Because I want to use a square and b square formula. And because I want to see whether it's a square number. Do we have a square, for example, a 9 in 1 to 9 or like 4 squared or something? The 2 is outside. If you times that 2, what you have is 2x minus 11 over 4 squared minus 1 to 9 over 8. And then the 2 is not get squared. You can't use a square minus b square formula. That's why I take the 2. I just forget 2 outside. And everything's inside. I'm just trying to factorize the inside terms. So this 2 is here, and what I have is x minus 11 over 4 plus 1 to 9, square root 1 to 9 over 4, and x minus 11 over 4 minus square root 1 to 9 over 4. Well, you can times the 2 in one bracket. You can times the 2 with this bracket or that bracket to combine the 2 inside, or you can leave it outside like this. So it doesn't really matter. But this 2 is outside the whole bracket because I want to use the a square minus b square formula. If I expand the formula, the 2 will not get squared, and then we can't use the formula. That's why we put the 2 outside. Yes? You don't need to. If you want, you can. But the thing is, if you combine it, this is 2x minus, okay, this one is 11 minus root 1 to 9 over 4, and this one is minus 11 plus root 1 to 9 over 4, if you want to combine them. So this one will be the minus, because you put a bracket around those two, the plus sign will become minus, so it's minus 11 minus 1 to 9, and this is the 11 plus root 1 to 9. But you don't need to, you can just leave. I prefer the answer looks like this. It's easier to think. Well, as I said, you can times the 2 within one bracket. Which one you decide? Like, for example, this one, I can go plus 2x minus 11 minus root 1 to 9 over 2, and then x minus 11 plus root 1 to 9 over 4. The 2 can only goes into 1. Okay, it's like 2 times a times b, so it's either 2a or 2b, so not 2a 2b. Okay, so the 2 only goes in one bracket.
Those 2a 2b will be 4?
Yeah, it will be 4 in front. So, well, you can say the other 2 factors are those 2. No, you can leave it outside. Get it? Oh, good. Back to the page. Okay, next page, example 7. Okay, for example 7. Okay, for this question, it's very important. Okay, this is factorize a cubic, or later we'll learn factorize quotic, but that's the basic. So the whole chapter is about factorization. Okay, the whole chapter is about factorization. So all the questions we have above, the question itself got some hints, like what is one factor? It's already given to you. For example, this one, it already tells you x minus 3 is the factor, so we know one factor already. Or like the previous question here, let's say it tells you divide by x plus 1, and you try minus 1, you have 0. You know that x plus 1 is a factor, so you all get some information already. But now for this one, there's no information. Okay, it just tells us nothing. It tells us nothing, so we need to find a value which can make it work. Okay, we need to find the value which is a factor. So we try one value to make it work. So what we could try is we look at the coefficient of the leading term and we look at the constant. We look at two places, which is the leading term's coefficient, and this one is a 1. And then we look at the constant. And we find a factor in that constant. So this constant, we have plus minus 1, plus minus 2, plus minus 3, and plus minus 6. Well, this coefficient is 1, so we just have plus minus 1. So we have the positive or negative. Okay, then those values are the values you will try. Okay, you will start to try. Well, I don't know which one will work. I need to try to make it work. So what we need to try, for example, the px equals to that. So you will see whether p1 equals to 0 or not, or p2 equals to 0 or not. Which one equals to 0? X minus a will be the factor. Okay, but I don't want you to try like p1, p2. That's the method. Go on to the book and then they do long division to find the rest of it. What we can start with is directly use this table. Okay, we directly use this table. So the coefficient is 1, negative 2, negative 5, and 6. And then I put the number I want to try here. Well, I will try something which not work first. Okay, we'll try something which doesn't work. So you don't need to write that. So for example, I tried 2. Oh, I'm not sure if 2 works or not. Well, anyway, just try 2. So I tried 2. The first number is 1. 2 times 1 gives you 2. 2 minus 2 will be 0. 0 times 2 is 0. Minus 5, we have minus 5 here. Minus 5 times 2 gives you minus 10. Minus 10 plus 6 is minus 4. This one doesn't work. Okay, this one doesn't work. We can see the remainder is not 0, which means x minus 2 is not a factor. So the good thing about this table is I can keep going with this table. Okay, this one doesn't work, right? So, well, give you some information. So what we try is normally plus minus 1 and then plus minus 2, and then we try from the smaller number, so 1 or negative 1. So I try 1 here. So this row is not working, so I don't look at that anymore. Then the first number is 1. 1 times 1 gives you 1. 1 minus 2 gives you minus 1. Minus 1 times 1 is minus 1, plus minus 5 is minus 6. 1 times minus 6 is minus 6, plus 6 is a 0. This one is a good number. Okay, this one is a good number because I got remainder 0. Why I don't want you to try P1, P2, P3? Because when you substitute, then I got the 0. And then you need to either go back to this method or you need to use long division. So this table will directly shows you whether it works or not, and also what is the rest of the quadratic looks like. So you can do two things in one time. So what I will have here is x minus 1 will be a factor because 1 is the right number. So x minus 1 will be the factor, minus a. Then what else here is x squared minus x and minus 6. X minus 1, and then the coefficient of x squared, x, and then the constant. So we have 1x squared minus 1x and minus 6. and that equals to x minus 1. We can factorize that easily. That's x minus 3 and x plus 2. Any questions? Okay, this is an easy question. Sorry, what? What do you mean by more than one factor? P equals to which? This? 6 won't work, but 3 and negative 2 will work. Okay, see the factor? That's the 1, that's the 3, that's the... Well, anyone will work. You just find one will work, yeah, and you find the other one. The quadratic may be different, but like you will, in the end, will have the 3 factor here. Well, I'm trying to find one question because the other two, which is a little bit different. I want you to try factorize 1. Which is example 4, not example 4, example, which one is that? Not that one, not that one. This one, page 63 and example 9. Well, it's equals to 0, but doesn't matter. Well, equals to 0 doesn't work. Just forget equals to 0. So I want you to factorize the left hand side by using the same method here. So try this method. So 30 can give you a lot of factors. Okay, can give you a lot of factors. Well, just wait a second. 30 get plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 5. Okay, plus minus, not 4, plus minus 5. And then plus minus 6, plus minus 10, plus minus 15, and plus minus 30. Well, I reckon the second line will not work. Think about this. Even though I said normally we start trying numbers start from 1 or negative 1. Let's have a think. Will you start to try using 1 or negative 1 in this case? Let's have a think. What's the coefficient of each individual term? If you sub 1, well, ignore minus 1 or positive 1. It's only the sign is different, right? So the number you have is 1, minus 1, 4, 11, and 30. Do you think those 4 numbers will give you a 0 by adding or subtracting? No, it's just not going to work. Okay, 1 is just not going to work at all by looking at the coefficient. So you need to do like maybe start from 2 or 3 because 1 is waste of time. You can see 1 will not work because doesn't matter you sub 1 or negative 1. The 4 number you can get is only 1, 4, 11, and 30, and then the only difference is adding or subtracting. By those 4 numbers, you're not going to make a 0. So it's not going to be the factor. So you will start to try maybe from 2 or 3, maybe 2. Okay, so that's why 1 does not work. 1 does not work. Okay, try that by yourself. Well, we tried 2. Well, 1 doesn't work. We tried 2. We have 1 here. 1 times 2 equals to 2. 2 minus 4 equals to negative 2. Negative 2 times 2 is negative 4. Negative 4 plus minus 11 is minus 15. Minus 15 times 2 is minus 30. Plus the positive 30, you have 0. So this one works. Okay, this one works. So x minus 2 is the factor. And what we left here is x squared minus 2x minus 15. That equals to 0. So we factorize the left hand side. X minus 2, and we have x minus 5 and x plus 3. Okay, x minus 5 and x plus 3. Also, this is a solving question. I can solve that. So x equals to 2 or 5 or minus 3. That will be non-factor law. Okay, either this equals to 0, middle equals to 0, or the last equals to 0. So non-factor law. After we factorize it, we can solve for it. It's same as the quadratic, solving for quadratic. So therefore, if you can see question 10, the 2 here is not good. So what we need to do, I'm not going to solve for it, but I just tell you the 2 needs to be moved to the left and make 0 on the right hand side. All the polynomials, if you want to solve for them, the right hand side needs to be 0. Or at least one side needs to be 0, because I want to use non-factor law to solve for it. We factorize it first and then use non-factor law. So one side must be 0. Alright, let's go back. I'm not going to do that one now. Let's go back to example 8. Okay, this question is called rational root theorem. So it's not really something will be tested very often, but it's better you know this. When we may use rational root theorem is when you got a coefficient for the leading term, which the coefficient is not 1. When the coefficient of the leading term is not 1, we may think about the rational root theorem. So let's have a think about as last time. I said what could be the number you try. So this one you got plus minus 1 and plus minus 2. What's us to try? And then the minus 3 got plus minus 1 and plus minus 3. I could try as well. There are 6 numbers, which is plus minus 1, 2, 3. And I will tell you some nightmare is all of the 6 numbers will not work. I'm not going to let you to try them, but you can try 1 or 2. It's not going to work. Well, we can see 1 is not going to work. Let's just draw a table. No, not always. Sometimes you can. Sometimes the integer works. We don't need to go through the rational root theorem. No, you must try them. Yeah. So, or you can see a coefficient. You may think, oh, that might be the theorem. So I may directly go to the fractional number to try. Let me finish, and if you have questions, then you ask. Okay, so what we need to try, what we need to put as normal is 2 minus 1 minus 1 and minus 3 here. So if I try 1, for example, if I try 1, so 1 gives me 2. 2 minus 1 gives me 1. That's 1. That gives me 0, and that gives me minus 3. That doesn't work. If you try all of these 6 numbers, plus minus 1, plus minus 2, plus minus 3, none of that will work. Okay, so if you try them. So in this case, all the integers not working, what we need to think about is we can create more number worth us to try, which is the fractional number. So what is the fraction will looks like? It will be, well, the fraction will be the factor of the constant over the factor of the leading term. Okay, the factor of the constant over the factor of the leading term. So what we can have is the combination of, well, what we have is 1 and 3 of the coefficient of the constant. So it's either plus minus 1 over something and 3 over something. And over the coefficient of the leading term, is either 1 or 2. You're not going to put it over 1. So it's still the constant, the integer. So we'll put that over 2. It's either over that or over that. You're not going over 1. Over 1 is still that same number. It's not changing. You need to over 2, right? Like 1 is still 1 or 3.
But if it was
No, like 205. Yeah, you just, yeah, both. Question? Any question? Another number will work because all the 6 numbers is not working. Well, because, well, I haven't shown you, but you can see 1, 2, 3, 4, 5, 1, 2, 1, 2, 3 plus minus is not working. So I need to find another number will work, because if those 6 is not working, you can't just randomly try 5. 5 is not going to work. Okay, if it works, it will only be those numbers. But if it's not working, I need to think about some more things can make it work. So that will be plus minus 1 over 2 or plus minus 3 over 2. Let's try 1 over 2. Let's try 1 over 2. So if you try 1 over 2, well, this one doesn't work already, so I cross that out. I just randomly select one. I don't know which one works. So I put the 2 down, and 2 times a half gives you 1. 1 minus 1 is 0. And then that's minus 1. And you can see that's not working. Okay, already you can see it's not working, because minus 1 times half gives you negative half. And then plus the negative 3 is negative 7 over 2. This one doesn't work. Don't worry, we have another number. Let's try 3 over 2. Well, you can have the negative as well. You can have the negative as well. But let's try 3 over 2. I get tired of it. I think 3 over 2 should work. So 2 is there, and 3. 3 minus 1, which is 2. And 3. 3 minus 1 is 2. And 3. 3 minus 3 is 0. That one works. No, well, it doesn't matter. So the factor will be x minus 3 over 2. And then what we left with is 2x squared plus 2x plus 2. Okay, that's what we have. No, when we try things, we'll never divide it by 2. It's when we do this. When it's given to us, it's 2x plus 1. It's something given to us. Like, why just try it by myself? Like, I don't care about, like, this. Like, it's just x minus the number I try. So what I can see here, we have 2, 2, 2 in the coefficient. Well, in the second bracket. I can take the 2 outside. Why I want to take it outside? Because I want to put into the first bracket. That looks better. Well, it don't really need to, but that's what I can do. Give the 2 to the other bracket, it looks better. And can I keep factorized? No. What's discriminant? 1 minus 4, so less than 0, so cannot factorize. The answer will stay like this. Okay, so your homework is to try this one by yourself. I don't want to show another one. I will tell you all the integers not working. Okay, all the integers not working. You directly start from the fraction. I have tried it for you, so it's not working. So you try the fraction. So what fraction will we have? Yeah, so that's plus minus 1 plus minus 3. That's plus minus 1 plus minus 5. So the new thing we have is plus minus 1 on 3 and plus minus 5 on 3. Those four numbers. Yes, but I think you have the test tomorrow. No one wants to do it. Better not. Just those things. Okay, I have a little bit to finish. Two access to bottom two, those two. You do this number 2 by yourself, and we do this together. How I can factorize this? X squared, not minus. Okay, plus what? 3x plus 9. Which formula we use here? A cubed minus b cubed. Okay, that's something I ask you to remember, maybe the first or second lesson, I can't remember. So that's the formula here. So we can write this as x cubed minus 3 cubed. X cubed minus 3 cubed, and that equals to x minus 3, x squared plus 3x plus 9. And another thing I want to tell you is, if you use this formula, this quadratic cannot be factorized for sure. Okay? Cannot be factorized. You can check the discriminant here is less than 0. So if you use this formula, the quadratic you have cannot be factorized. Okay, what's this one? So I can make this into 2 cubed plus a over 3 cubed. So I will have 2 plus a over 3, 4 is minus the formula is a cubed plus b cubed equals to a plus b, a squared minus ab, and then plus b cubed. It's just a formula thing, okay? It's not nothing y, like it's just use the formula. Well, if you really want, you can take a 1. You can take a 1, 9 outside this bracket. Well, if you take 1, 9, that's a squared minus 6a, and then plus 36. And it can't be factorized. Just equals to 0, and then there's no solution for that one. It can't be 0. You only have one solution then. And I can also take a 1, 3 out, which make a 1, 27, and then this become a plus 6. And then a squared minus 6a plus 36. You don't really need to. You can make your answer stay like that. But you need to see that's a quadratic for the second bracket. That's a quadratic. And then this quadratic cannot be factorized. Okay, everyone, because tomorrow is the test, we don't really go through any teaching tomorrow. So your homework for the weekend is, I'm not going to check your scheme of work yet, but I will check your homework to factorize those two pages. Okay, use any method you can to factorize page 62 and 63. You can factorize that.
So do we have to stay here?
Yeah, you need to stay in the room. Okay, so page 62 and page 63. And if you missed the lesson yesterday, you need to go to watch the video from yesterday because there's a lot of teaching there.